We begin by multiplying 4x times x quantity x minus 3 plus 5x times quantity x squared minus 5x plus 7. We use the distributive law. 4x multiplied by x minus 3 is 4x multiplied by x minus 4x multiplied by 3. 5x multiplied by x squared minus 5x plus 7 is 5x multiplied by x squared plus 5x multiplied by negative 5x plus 5x multiplied by 7. And I see a little inconsistency in the way I wrote this out, so I'm going to correct that and discuss it. Okay, I didn't like the way this term was written anyhow because I had an unnecessary set of parentheses around the x, but the inconsistency, and there's nothing incorrect about the way it was, I just think it's clear this way, where we see that we're multiplying 4x by negative 3 rather than putting the negative out in front. Now obviously that's something you will kind of do naturally. You probably put that negative out in front, but in exhibiting all these steps in a consistent manner, that's what I choose to do. Okay, so 4x times x, 4x squared. 4x times negative 3 is negative 12x. 5x times x squared is 5x cubed. 5x times negative 5x, negative 25x squared. 5x times 7 is 35x. Then we collect terms. Now this is really an application of the distributive law, and you'll see what I mean. First of all, I've only got one x cubed term, and I want to write this out in decreasing order. Excuse me, in decreasing order of the powers. So I'll start with a 5x cubed. Now when I get to x squared, I've got a 4x squared and a negative 25x squared. Now we all know that that's going to give us negative 21x squared, but to emphasize that that's an application of the distributive law, which makes everything clearer and more consistent if you get into a situation where you really need to think it through. We're going to say that I'm going to factor the 4 and the negative. I'm going to factor the x squared out of the 4 and the negative 25. I'll keep the x squared on the right because the distributive law works on the right as well as it does on the left. So I'm going to write this as 4 minus 25 quantity times x squared. And then similarly on my x terms, I'm going to write a negative 12 and a 35. Now I wrote that as 35 minus 12, so I kind of reversed the order, but that shouldn't be confusing. And factoring the x out of these two terms. So when I write out the entire expression, 4 minus 25 is negative 21, so I'm going to have negative 21x squared. 35 minus 12 being 23, plus 23, I have plus 23x. And that's the final result. Now, I've gone into more detail than absolutely necessary, but you should understand all those details. I'm doing the same thing now with x cubed plus 3 times x squared plus 5x minus 7. I have x squared times x squared. Excuse me. Now, let me pause for a second here and stop coughing the camera. There's a campus picnic going on. It must be the barbecue and the coleslaw. In any case, to do this, okay, I'm going to write x squared times this quantity. In other words, distributing across this plus. We get x squared times this quantity at plus 3 times this quantity. Very straightforward application of the distributive law. And then I apply the distributive law on each of these terms. I'm not going to read all that to you, except, we have the x squared times the x squared here, x squared times 5x here, x squared times 7 here, 3 times x squared here, 3 times 5x here, 3 times negative 7 here, and I just did read it to you, but it's okay. Make sure that we understand this. Then multiplying x squared times x squared, we get x to the 4th. X squared times 5x gives us 5x cubed. X squared times 7 gives us 7x squared, and so on. So all these terms are represented here. Then we have only one term, only one power of x that appears twice, as much as twice. Only one power of x, which is the x squared power, that appears twice in this expression. And we factor the 7 plus 3 out of the x squared, and 7 plus 3 of course, gives us 10. I don't know why. I know why I had erased that, because I had a mistake on I copied this down without a negative sign in class, and I was making corrections. Okay, I didn't really need one there. But okay, and we get this. So all that is quite straightforward.